Our experiment is how the different density of liquids have an effect on acceleration when dropped. We predict that the greater the density of the liquid, the more the balloon will accelerate. The honey will most likely accelerate the fastest, followed by the peanut oil, and then the water-filled balloons. The honey will accelerate the fastest because it is the most dense, while the water will accelerate the slowest because it is the least dense. The peanut oil will be somewhere in the middle. For our methods, we will fill 3 balloons with 3 different liquids, honey, peanut oil, and water, and drop them from a height of 8 feet to measure acceleration. We will have 3 trials for each balloon in order to get the most accurate results possible. At the end of our experiment, we will average each trial for each separate liquid and compare. We drop the balloon from a height of 8 feet in order to reduce error for each trial and to get the results as accurate as possible. We measured the height each trial with a measuring tape so the height and speed can be shown in each video taken. We were able to get each liquid into the balloon by using a funnel to pour the contents into a water bottle and then squeezing the contents into the balloon to avoid spillage. To conduct this experiment, we used various materials. We used 3 balloons, preferably all 3 different colors. We needed 1/2 cup peanut oil, 1/2 cup water, and 1/2 cup of honey, 3 empty water bottles, a funnel, a measuring tape, a marker, and a 1/2 cup measuring cup. Here's an example of all our materials. We then, to conduct this experiment, had to set up. To set up, we had to measure out 1/2 cup of honey, water, and peanut oil and place them in separate containers. We then got 3 empty plastic water bottles and one by one carefully used the funnel to pour the entirety of your measured contents into a separate cleaned water bottle. We then blew the balloon up a little bit to stretch it out, and then while pinching the neck of the balloon to not let any air out, we placed it on the top of our filled water bottle. We then flipped the water bottle over to pour the contents into the balloon. Now very carefully, we let the air out and then tied the balloon with a secure knot to ensure it doesn't spill. Repeat till all 3 balloons are filled and labeled with what liquid is filled in it. To execute this, we then took our filled balloons and used our measuring tape to measure an 8-foot drop. Then we dropped each balloon 3 times and took a video to record. We then put these videos into Vernier Video Analysis to get the data for each. Here's an example of how we dropped them. In order to use Vernier Video Analysis, there were a few steps we had to take to ensure the videos were properly analyzed. First, we had to download and email the videos to ourselves. Then, we had to set the system to scale. So, we used the size of the measuring tape as a scale of 8 feet. Then, we adjusted the x-axis and set the graph to measure the x velocity. Finally, we tracked how fast the balloons accelerated by placing 6 dots throughout the fall. For each of these dots, we are given a velocity and a time for the dot, which allowed us to find an acceleration rate for each substance. For the data, we used 3 trials for each substance to maximize the accuracy of the results. In order to average them out, we found the mean time, velocity, position of each data point for each substance. For the water data, the acceleration rate was found to be 13.829 feet per second squared. For the oil, the acceleration was found to be 14.722 feet per second squared. Finally, for the honey, the acceleration was found to be 16.434 feet per second squared. The increase in acceleration, a greater velocity, as the liquids are dropped shows that the greater density of the liquids leads to a faster acceleration. Along with this, the increase in the final velocity of the liquids further reinforces the idea that the greater density of the liquids leads to a faster velocity as the balloon is dropped. Our results showed that the acceleration increased as the density of the liquid increased, so this proved our hypothesis correct. The honey-filled balloon ended up falling the quickest with an average acceleration of 16.434 feet over seconds, while the water-filled balloon fell the slowest with an acceleration of 13.82 feet over seconds. The peanut oil-filled balloon had an acceleration of 14.722 feet over seconds, the acceleration rate being in the middle of the other 2 balloons as predicted.